We're going to be looking at integration, specifically how to integrate using a U-sub technique and how to integrate using a trig sub technique. Let's first start off with the U-sub technique. This is very useful when we can see a component is the derivative of another component. For example, say we have the integral of 6x times x squared plus 4 dx. Now, what we can see is that the derivative of the part inside the brackets is going to be 2x, and we are multiplying a 2x on the outside. So I could write u is equal to x squared plus 4. So what is the derivative of u? So du is going to equal to 2x dx, right? Because du over dx is going to equal 2x. Now I'm going to substitute these components back into our equation. So this is the same as integral. I'm just going to write it as 3 times 2x times x squared plus 4 dx, which is the same as integral 3, and the 2x and the dx pair up to form the du. Okay, and the x squared plus 4 is just the u. So we have 3u times du. Okay, and we can take the 3 out, so we have 3 integral u du, which is the same as 3 over 2u squared plus c. Don't forget the plus c. And now what we have to do is we have to substitute x squared plus 4 back into u. So this is going to be 3 over 2 x squared plus 4 all squared plus c. And this is our final answer. This is the integral of 6x times x squared plus 4. And the u sub was useful because we see that we are multiplying by the derivative of another component. In this case, the derivative was 2x, and we see that we are multiplying 2x to x squared plus 4. Okay? Now let me take another example. Let's do integral 2x times x squared plus 1 to the power of 3 dx. Here, again, we're going to use a very similar u sub. We're going to make u is equal to x squared plus 1. Because we have a 2x on the outside, and du is equal to 2x dx. Now we have all our components, and we can substitute everything back in. The 2x and the dx multiplied together just make the du, and the x squared plus 1 just makes the u. So I can just rewrite this as u to the 3 du. And if we just use inverse change, we just use our basic integration rule, that is the same as 1 over 4 u to the 4 plus c. And again, don't forget to substitute u back in. So this is the same as 1 over 4 x squared plus 1 to the 4 plus c. Okay, nice. Now we are going to go on to some harder examples. Integral of 2x over x squared plus 7 dx. Now this time, what I can see is that the derivative of the bottom part, x squared plus 7, will form a 2x, and we have an x term in the numerator. So the x times the dx will cancel out again. And let me show you what I mean. I'm going to set u is equal to x squared plus 7. So du is equal to 2x dx. And look, we have 2x dx right here, and that pairs up with this du. So 2x times dx is just du, and again, this x squared plus 7 is just u. So this integral is equal to 1 over u times du. And we know that this is going to be natural log of absolute value, don't forget that, plus c. And this is the same as we just have to substitute x squared plus 7 back in, plus c. And this is our final answer. Okay? Now let's move on to an even harder example, which involves some trigonometry. Tan 2x sec squared 2x dx. Okay, now again, a u sub will be helpful in this question because the derivative of one component is multiplied to dx, and that component is tan 2x. The derivative of a tan is sec squared, and we are multiplying by a sec squared. So let's see what happens when we do u is equal to tan 2x, and then take the derivative. So du is going to equal to 2 times sec squared 2x dx. Don't forget that part. Now, as you can see, we have all of our components. So this is going to be equal to integral. Let me just match everything up. This is just the same as u. And this together, the sec squared 2x and the dx, is just the same as du over 2. So I'm going to write du over 2 is equal to sec squared 2x dx. That's just the same as that. Now, let's combine these pieces together. We have u here, and we're timesing it simply by du over 2. So over 2 du. Now, I can pull out the half, integral u du, and this together is the same as 1 over 4 u squared plus c. And now we substitute the u back in, so we get 1 over 4 tan squared 2x plus c. The best way of getting better at these types of questions is just purely by practice and a lot of repetition. Okay? So let me cover one more for you. This is a lot about pattern recognition. You have to recognize where the derivative component is that you're multiplying by. Okay, so this is the integral. And again, we see that if we take the derivative of 1 plus x to the 4, we'll get something x to the 3. We'll get what? We'll get 4x to the 3. And we have an x to the 3 multiplied by dx up here. So let's set our u as 1 plus x to the 4. So du is equal to 4x to the 3. And I just want to make it x to the 3. So I'm just going to write du times 1 over 4 is equal to x to the 3. Oh, don't forget the dx part. Sorry. So this pairs up with this. And obviously, the part inside the square root pairs up with the u. So this is going to be equal to 1 over square root u, and simply just du over 4. Okay? And this is equal to, I'm going to take out the quarter, 1 over root u du. This is just the same as 1 over 4 times the integral of u to the negative a half du. And again, use our integration techniques. We add 1 to this, divide it. So we have 1 over 4 times 2x to the half, I believe. Let me just double check that. Half this, subtract 1. Perfect. Sorry, but not an x, it's going to be a u. And a plus c always. And this is the same as a half u to the half plus c. Now substitute our u back in. Half 1 plus x to the 4 raised to the half plus c. And that is our answer. Now I'm going to do trig sub in another video. The key to solving u sub questions is pattern recognition. You want to see where the derivative component is. And you get better at pattern recognition simply through just doing a lot of questions. So the best way to help you out is just ChatGPT, u sub integration questions, and you'll get a bunch of examples and work through them. That's the best way of getting better at these types of questions. Okay, you just want to find what the derivative component would be. So you want to do u is equal to the part that gets you the derivative. Okay, thank you very much for watching. I hope you learned something, and stay tuned for the next integration video.